Hello friends, welcome back to the channel. So when we talk about VLSI design, what it comes to our mind, I think it comes to Verilog, VSTL system Verilog, and design automation tools and all these things. But those are part of VLSI design. But what starts? It starts with functional specification of the VLSI chip itself. It also starts with what kind of type of VLSI design or VLSI chip it is going to be. So first phase it starts with VLSI chip design, and next step is basically VLSI chip manufacturing. But when we talk about functional specification of the VLSI design and we talk about what are the type of VLSI design, it comes to our mind that it can be a processor, it can be a memory, it can be a artificial intelligence chip, it can be any kind of chip. But every chip has some different functionalities which is being captured in the functional specifications. Now, in functional specification, how do we write? We start with writing some English sentences like, for example, this is my chip which has maybe 4 input and 2 output pins in the chip itself. We talk about that there are 2 clocks in my design. We talk about this chip is going to do some arithmetic calculations, etc. and etc. This is a very basic functional specifications. Now, the thing is that when we convert this functional specification and integrate it into the design process itself, how do we do? We do with the help of design constraint. So design constraint is a kind of syntax by which we write this specification. For example, if I have 2 clocks and I know that these 2 clocks are asynchronous to each other, I will write that 2 clocks in 2 different groups. I will also write that what is the clock frequency that I am expecting to work in this chip. And also, if I know that what is the total time that is required from input to the output, I can write these informations also. But those are things are more in detail. In general, what we discussed today is basically what is design constraint. Design constraint files, input files that we provide during the timing analysis. We do a timing check of the chip, whether this chip is successful or not. And in this timing analysis, we pass this design constraint input file. Design constraint input file contains this all type of functional specification in the form of design constraint. So we talk about that in today's video. We also talk about what is a little bit of timing analysis. We talk about what is formal design constraint concept. We talk about different clock constraint as well. But we will not go through the syntax oriented stuff, but we will more talk about the conceptual part of the clock constraint that is provided to the design development. So stay tuned till the end of the video to know all these things conceptually, so that it will improve the VLSI design process, and obviously if design improves and manufacturing becomes very easy to do. Stay tuned till the end of the video. Let's first start with the first design constraint, that is create clock. So we'll talk today about design constraint which is most popular. I think it is synopsis design constraint. So it is provided during the timing analysis process. So the first constraint we talk about, that is create clock. Create clock generally applied on the input pin of a particular block. So if you have a SoC and if you have an individual module block or ASIC, you can directly apply the input pin of the clock for this module block. So this does not mean that you want this design to create a clock on that point, but it is just for the applying some constraint on the particular block itself. So create clock has some parameters to provide, that is, one is period, another is waveform, another is basically the particular pin name where you want to provide the create clock, etc. etc. Today we'll talk about more on the conceptual side of the things. So you can go and find the help page or man page for create clock in synopsis design constraint file. So this is create clock. This create clock is basically provided on the module boundary. Next is create generated clock. Any clock which is specified inside this module block, any particular pin, maybe it is a register pin or maybe it is any kind of input combinational pin, there is create generated clock is applied. Create generated clock is derived from the create clock, and generally it is if a create clock has a 10 nanosecond of period, then we can divide this period by 2. That means the create generated clock will be 5 nanosecond in period. There is some different things like the source of the pin where the create generated clock can be applied. It can be multiplied by or it can be divided by things, and etc. etc. Different syntaxes for create generated clock. The concept is that you can create as many create generated clock possible inside your design based on the master clock which is provided on the module boundary. Next is basically the clock transition. Clock transition is basically the clock value changes from 0 to 1 and 1 to 0. But it does not change suddenly, so there is a inclined line by which it changes from 0 to 1. It takes some time. This time is captured with the help of clock transition. That is important to know for particular setup and code analysis, but we will not discuss about today about all these things. Next is basically the clock latency. Now, what is clock latency? Clock latency is basically the clock delay. It can be two types. One is source clock latency, another is network clock latency. So when there can be an off-chip clock which is situated outside this module, so from that off-chip clock source to the particular module boundary clock where it is create clock applied, this is called clock source latency. And from that particular module boundary to actual point where this clock is being driven, that is the register point, register pin, this is called clock network latency. So you can specify clock source latency and network latency separately with the help of the parameters by specifying minus source or minus network. So this is very important because if we do not consider this in the pre-layout state, that means we are being very optimistic in our timing analysis. But generally what happens, this clock path does not exist in the post-layout state of the design where there is actually some clock tree is being generated. But still, for some assumptions, we put some value for clock delay in the pre-layout stage with the help of this set clock latency. Set clock latency can be of two types. One is intra-clock latency. That means set clock latency is basically not of two types. It is basically the set clock uncertainty. Uncertainty is basically two types: intra-clock uncertainty and inter-clock uncertainty. If it happens, clock uncertainty is basically when you have a period of 10 nanoseconds. That means that your rising edge and the falling edge both becomes 10 nanosecond and 10 nanosecond. But this is an ideal concept. It does not generally happen like this way. Your positive edge, your positive time 10 nanosecond for the positive value, and when the clock becomes negative, it can be 8.5 nanosecond or 11.5 nanosecond. So there is a difference of 1.5 nanosecond from the rising edge to the falling edge. This is called clock uncertainty, and it is very important to calculate all these things for the timing analysis report. It can be two types. Clock uncertainty can be two types: inter-clock uncertainty, that means clock uncertainty among different clocks, or it can be intra-clock uncertainty, which can be clock uncertainty among different positive edge and negative edge of the same clock itself. So this is called set clock uncertainty in the timing design constant, I would say. Next is basically is important as well as new concept, that is clock group. If you know that you have multiple clocks in your design and you know that this clock will not interfere with each other, then clearly you can mention that these clocks are belongs to two different clock groups. That means there will be a false path automatically being considered between these two clocks. This is basically used when the portion of the design becomes asynchronous compared to the other portion from the design itself. So these are all, I think, the clock, the concept of the clock design constant. So let's do a recap of what I discussed today. I discussed about the functional specification of a design. I discussed about the concept of design constraints, why it is required. I discussed about what are the different types of all clock design constraints in these discussions. And also I discussed about different few of the timing analysis terms that I have talked about, that is required to analyze the design constant. So design constant is basically required as an input file for the timing analysis. Timing analysis report is generated to get the timing of a particular circuit, whether it is working as expected or not. So based on that, what is your thought? If you directly work on the timing analysis, I'm sure that you know many things about the timing analysis and design constants here, specifically the clock constant. We have only mentioned the clock constant conceptually in this video itself. Even though if you are a generally curious minds, and if you are not into the timing analysis but you know conceptual timing analysis, what is your key point of timing analysis? What is your experience? I would like to know that when you apply this timing analysis or timing design constant, and when you are doing the timing analysis, what is your experience? Please let me know in the comment section of the video. Also let me know whether this video, how much it gives a benefit to you, whether you have some conceptual things that got cleared in this video itself. Also let me know if you have some query or questions in the comment section of the video. And if you have liked this video, please press the like button. Also subscribe this channel and share this video for the better reach itself. Last but not the least, I'd like to mention that I have recently published a book called Semiconductor for All that discussed about semiconductor topics, including EDA topics and also semiconductor manufacturing and artificial intelligence. So I would highly recommend that you can buy this book It is available in the Amazon Kindle version. I will provide the book link in the description section of the video. So I think that's it for today. Wait for the next video to come. Till then, Subhasish Chakraborti signing off.